Hello friends, if you still not subscribed our channel then please subscribe it and then also click on bell icon. If you want to ask any question then you can also join our Discord group. Link in description. So, today I am going to tell you about crazy new paper suggests wormholes cast shadows we could easily see with telescopes. So let's start. The hypothetical cosmic portals linking 2 points of space-time that we call wormholes are the stuff of science fiction and space theory right now, but if they really do exist, one scientist has come up with a way we might spot them, by the shadows they leave. It's similar to the way that we spot black holes, not by looking at the objects themselves, but rather at their ripples and the effect they have across the rest of space. That sounds straightforward enough and it's something that's been proposed before, but one challenge of this approach is figuring out how the shadows from black holes and wormholes would differ. And, of course, knowing what to look for. Now a new paper has laid out a hypothetical way wormhole signatures might be detected and distinguished from those of black holes, kind of like an X on a cosmic treasure map. It's just possible that one day this mathematical map model might help us to confirm whether there are actually wormholes out there in the universe. The results obtained here indicate that, through the observations of their shadows, their wormholes which are considered in this work and have reasonable spin, can be distinguished from a black hole, says physicist Rajai Bilshaikh, from the Tatu Institute of Fundamental Research in India. Wormholes are most often mentioned in sci-fi movies as ways of jumping great distances through space or across time, as if by magic. The way it works in theory is almost as if space folds over on itself to connect 2 points in 4 dimensions that were previously very remote from each other, though wormholes can also cover very short distances or time periods. And while that all sounds fantastically improbable, scientists are determined to keep investigating. Wormholes have been theorized about for nearly 100 years, and they're consistent with Einstein's theory of general relativity. In more technical terms, they're parts of space where light no longer travels in a straight line. Light particles bend around a wormhole, astrophysicists think, and particles that get too close fall into the void, creating a shadow. That's where the new research comes in. While calculations have been run on wormholes before, Sheikh says his new model takes into account the throat of the wormhole, the connecting channel, to end up with a more accurate prediction. The calculations suggest that while the shadows of slow-spinning wormholes would appear identical to the circular shape of a black hole, faster wormholes would produce more distortedly shaped shadows, making them easier to distinguish. If they exist. In the observer's sky, the scattered photons form bright spots, whereas the photons captured by the wormhole form dark spots, explains Sheikh. The union of the dark spots in the observer's sky constitute the shadow. It's worth reiterating that this study only focuses on one type of wormhole, a TOE-class rotating wormhole, and while Sheikh has submitted his paper to the Physical Review D journal, it hasn't yet been peer-reviewed. It's currently published online in preprint journal Arcsif. At the same time, it's such an intriguing concept that any new research on wormhole formation is going to pique our interest. Even the models that end up missing the mark could help us one day work out whether or not wormholes actually exist. And that might not be so far off. Scientists are hard at work on a new Event Horizon Telescope, EHT, that just might help us take a good long look at black holes directly. If it can see black holes, it could theoretically see wormholes too. The EHT is actually a network of telescopes that could provide the magnification required to see a black hole, not just its effects on space. The first batch of data from it is now being analyzed, and this research could help us make sense of it. There's still a lot we don't know about wormholes and how matter might react in them, which makes modeling them difficult. They are hypothetical after all. Physicist John Friedman from the University of Wisconsin-Milwaukee, who wasn't involved in this study, isn't convinced that the types of wormholes the research looks at actually exist. It's highly unlikely that macroscopic wormholes exist, Friedman told Live Science. If they do, the unknown nature of the matter supporting the wormhole makes it impossible to predict the shadow. Nevertheless, Sheikh is confident in his calculations. It will be interesting to see whether or to what extent the conclusions drawn here carry over to a broader class of rotating wormholes, he concludes in his paper. Hope you like this video and subscribe my channel. Thanks for watching.